Today we're diving into something deceptively simple but insanely powerful: Python's iterators and generators. If you've ever wondered how to process huge datasets without melting your computer's RAM, this video is for you. Iterators give you tight, low-level control over how data is accessed. Generators, on the other hand, let you pause and resume execution, making them your best friends when handling large files, streams, or infinite sequences. Let's jump in. Let's start with iterators. You might not realize it, but you've already been using them. Every time you write a for loop in Python, you're relying on an iterator behind the scenes. For example, lists are iterables. They don't return items one by one themselves, but they know how to hand over an iterator that does. But what if you want full control, like deciding exactly when to stop, or how to generate each value? That's where custom iterators come in. To build one, you define a class with two magic methods, iter and next. Here's a simple example. When you run this, you'll get 1, 2, 3, 4. Here's what's happening. The iter method returns the iterator object itself, usually self. The next method produces the next value, and when it's done, it raises a stop iteration exception. This signals the loop to exit gracefully. This setup is perfect when you need precision. For example, paging through an API or each response gives you just a chunk of data at a time. Writing a whole class just to iterate might feel overkill, unless you got some kind of twisted joy from it. In that case, no judgment, carry on. But if you'd rather keep things lean and readable, generators are your best friend. They do all the heavy lifting of iterators, but with way less boilerplate. Let's revisit the same counter example using a generator function instead. This prints 1, 2, 3, 4, just like before. So what's happening here? The yield keyword is doing the heavy lifting. When Python hits yield, it pauses the function's execution and saves its state. When the next value is requested, it resumes right where it left off. No need to track everything yourself. Generators are incredibly handy when dealing with streams of data, infinite sequences, or any case where you don't want to hold everything in memory at once. So when should you actually use a generator instead of a regular function? The key moment is when memory matters. If your function is going to return a ton of values, storing all of them in a list might be wasteful or even crash your machine. With generators, you process one item at a time, no big memory spikes, no long waits, just clean, efficient iteration. Think about reading logs, streaming sensor data, or processing millions of database records. These are generator territory. Let's bring this idea into the real world. Imagine you're working with a massive log file, say 10 gigabytes. You definitely don't want to load that entire file into memory. Your computer will either start gasping for air or just flat out crash. Instead, let's read it line by line using a generator function. So how does this help you? Well, in data science, or really any case where you're working with large datasets, you might need to scan through huge files looking for something specific. Let's say you're trying to find a birth date buried somewhere in a sea of data. You could load the whole file into memory and search through it, but that's risky. Your computer might start overheating like a volcano. With yield, Python reads just one line at a time, processes it, and then discards it from memory before moving to the next. It's like flipping through pages of a book instead of trying to memorize the entire thing at once. Generators also play well with Python's expressive syntax. Do you remember list comprehensions? You can see my short if you haven't. But did you know you can turn that into a generator expression just by swapping the brackets for parentheses? This looks and behaves like a list comprehension, but here's the kicker: it doesn't build the whole list in memory. Instead, it generates one value at a time, only when needed. That means lower memory usage and quicker startup. It's perfect for things like processing large datasets or streaming data. Or at least that's what the pros say. Personally, I just think it looks cool and it's a neat trick to have in your toolbox. Now it's your turn. Write a generator that processes something big: log files, database rows, live data, or even the Fibonacci sequence. If this helped make generators click for you, hit that like, tap subscribe, and tell me in the comments how you're using generators in your own projects. And as always, I'll see you in the next dimension.